Hi folks! Today I'm going to show you a self-reduction between relations. A self-reduction is a quick reduction from a search problem to its decision version. If you find a mistake in what I say or wish to share with me with your thoughts, please comment below. Also, please subscribe to my channel and click that bell icon. BR a relation in PC, polynomial check. In other words, given a pair of x and y, a problem and its solution, we can check in polynomial time if y is the solution for x. There is a quick reduction between the relation R and R tag. R is simply a generic relation of pairs of problems and solutions, while R tag, on the other end, separates the solution y into its prefix and suffix parts. Our goal is to prove a self-reduction from SR tag to SR. Let's look at the solution. Okay, so our goal is to show that if it is possible to verify a couple of problem and solution in a polytime, we can solve the relation in a polynomial time, given the relation R is in PC, SR in NP. That's because there is a polynomial verifier VR that receives a couple of XY, problem and solution, and returns true if and only if XY are indeed a couple of a problem and solution in R. Additionally, NP is a subset of P. Therefore, SR in NP, which is a subset of P. Now, we'll look at SR, the prefix problem. Given a solution y, I request all substrings of y from the empty substring all the way to y itself. We will notice that SR, the prefix problem, is also in NP, because it has a verifier in NP. Given that there is a quick reduction from SR tag to SR, we understand there is an oracle that we can refer to via SR tag, the prefix problem. Therefore, if the oracle returned that the prefix we sent to it is part of y, the string of the full solution, we can proceed to the next bit. Otherwise, we will change the last bit of the substring we sent to the oracle and send another bit until we found y itself in a linear time, because it is tied to the length of y, which is on. Example: say that y equals 100,101. Okay, so the first question we are asking the oracle is if 1 is a substring of y, and we're getting the answer yes, because indeed y is a substring of y. Moving on. Is 11 a substring of y? Well, this time we're getting no, because the second bit is 0. So, because alphabet of y is 1 and 0, we know that the second bit must be 0. Good. Now, we are asking if 101 is a substring of y, and we're getting no again. So the third bit must be 0 as well. We are sending now to the oracle the substring 1001 and getting the answer yes. See? Okay, good. Now, moving on. 10011. This is now what we're sending to the oracle, and we're getting the answer no, because a substring of 5 letters of y is 10010. So we know that. Moving on, we're sending 100101, and finally we found y. Good. Okay, so here is the proof. Assume that xy is indeed a couple in R. According to the described algorithm above, we can find y in a polynomial time. Therefore, PC implies PF. Second direction. Assume that using the described algorithm, we found y. So given R in PC, we can verify the solution in a polynomial time. Therefore, PF implies PC. That's great. In conclusion, there is a self-reduction to R as required. Well, that's the story. I hope you learned something new from this video, and please comment below with your thoughts. First degree studies in university are all about social studies, and this project comes to encourage that, even through complicated situations most of us are going through right now. Thank you so much. Good luck.